You're down to your last options, and water is no longer something you can take for granted. It's not because you didn't plan, but because history has proven again and again that the moment things fall apart, clean water disappears first. Armies have collapsed over it. Cities have died from it. Entire expeditions have failed, not from lack of courage, but from what they drank. And yet, buried in the records of civilizations separated by oceans and centuries, there is a pattern, one so consistent, it stops being coincidence and starts becoming something far more important. A principle, a method. Something that works whether you understand it or not. Stay with me, because what you're about to learn isn't theory or modern survival hype. It's a method observed by Egyptian healers treating battlefield wounds, refined unintentionally by Greek sailors trying not to die at sea, echoed by civilizations that never met each other, and later confirmed by modern science under conditions far more extreme than anything you or I will face. By the end of this, you won't just understand it, you'll know how to use it when it actually matters. This is where history stops being something you watch and starts becoming something you use. The earliest evidence comes from a place where survival was brutally practical and mistakes were paid for quickly. Along the Nile, Egyptian healers weren't experimenting for curiosity. They were trying to keep wounded soldiers alive in an environment where infection killed more reliably than weapons ever could. What they noticed was simple but profound. Water stored in copper vessels behaved differently. Wounds cleaned with it healed more often. Those treated with untreated river water did not. There was no language for bacteria, no understanding of microbes, no chemistry as we know it. But there was observation, repetition, and outcome. And the outcome was clear enough to be written down in some of the earliest medical texts that still exist. Copper was not decoration. It was survival equipment. Centuries later, Greek sailors faced a completely different problem, but arrived at the same conclusion. Long voyages meant storing water for weeks under heat that turned wooden barrels into breeding grounds for disease. Dysentery and dehydration wiped out crews before storms or enemies ever could. But when water was kept in copper containers, something changed. It lasted longer. It didn't foul as quickly. Men stayed functional. Again, no microscopes, no lab tests, just results that could not be ignored. The Romans, being engineers at scale, didn't just observe this, they built with it. Copper became part of water systems, part of infrastructure, part of daily life. Not because they understood the underlying science, but because it worked consistently enough to justify the cost. What makes this even more compelling is what happened on the other side of the world. Civilizations in the Americas with no contact whatsoever with the Mediterranean world identified the same effect. Copper-treated water appeared in healing practices, rituals, and daily use. In India, the practice of storing water in copper vessels has persisted into modern times. It's passed down not through scientific papers, but through tradition that refused to die out because it kept proving itself useful. When separate cultures arrive at the same solution, without ever communicating, you're not looking at shared knowledge. You're looking at a universal rule waiting to be discovered. For a long time, this knowledge stayed embedded in daily life. Then industrialization changed everything. Cheap materials replaced durable ones. Plastic replaced metal. Chemical treatments replaced passive systems. The priority shifted from longevity and simplicity to scalability and cost. Copper didn't stop working. It simply stopped being convenient for mass production. And like many things that don't fit industrial efficiency, it faded into the background. It resurfaced not through some grand rediscovery, but through accident. A researcher working with treated water noticed something strange when metal made contact with it. Chlorine, which had been deliberately added, began to disappear without additional chemicals or energy input. That observation led to deeper investigation, and eventually to a clearer understanding of what had been happening all along. At the core of this process is something called a galvanic reaction. When two different metals, specifically copper and zinc, touch each other in water, they create a tiny electrical current. Not enough to power anything you'd notice, but enough to trigger very real changes at the molecular level. Zinc naturally wants to release electrons. Copper is more stable and accepts them. When they're connected in water, electrons begin to move from one to the other. The water itself completes the circuit. What you get is a continuous, low-level electrical activity happening inside the container. This is where it stops sounding simple and starts becoming powerful. That tiny current alters the structure of chlorine, turning it into a harmless compound. It pulls certain heavy metals out of the water and binds them to the metal surface. And most importantly, it disrupts the internal processes of bacteria, making it impossible for them to survive or reproduce. The environment becomes hostile to contamination without adding anything artificial. This is not speculation. It's been measured, tested, and applied in controlled environments where failure is not an option. When space agencies were designing life support systems for missions where resupply was impossible, they faced a problem very similar to what ancient sailors dealt with: how to maintain safe water in a closed system. Boiling wasn't efficient. Chemical treatments had drawbacks. What they settled on was a method that introduced metallic ions into the water supply, effectively controlling microbial growth without heavy equipment or constant intervention. Different tools, same principle. So now, you're looking at something that has survived 4,000 years of human use. Independent discovery across continents, validation through modern science, and application in environments far more unforgiving than anything on Earth's surface. At that point, the only question left is whether you can actually use it. The answer is yes, but with precision and realism. If your water source is visibly contaminated with dirt, debris, or sediment, the first step is purely mechanical. Strain it through cloth or any tightly woven fabric. This doesn't make it safe, but it removes the larger particles that interfere with further treatment. The core of the method is the interaction between copper and zinc. You need direct contact between the two metals. It's not separated, not loosely placed together, but physically touching. Twisting them together ensures a consistent connection. Once placed in water, time becomes the critical factor. This is not instant. The reaction builds and works steadily. A few hours will begin the process, but longer exposure significantly improves the outcome. While that's happening, the system is addressing biological threats and certain chemical contaminants. But no method is universal, and this is where most people make mistakes. They assume one solution covers everything. It doesn't. Organic pollutants, agricultural chemicals, and certain resistant parasites require additional steps. Charcoal, specifically from natural wood, has the ability to absorb many of these compounds. Passing water through a layer of crushed charcoal improves both safety and taste. For organisms that resist chemical disruption due to protective shells, physical filtration becomes necessary. Materials like diatomaceous earth, formed from microscopic fossilized structures, act as a fine sieve. Water can pass through, but larger contaminants cannot. When you combine these stages, basic filtration, galvanic purification, chemical absorption, and fine physical filtering, you move from a single method to a system. Each part compensates for the limitations of the others. What you end up with is not a gadget or a product, but a process. One that doesn't depend on electricity, doesn't require constant replacement parts, and doesn't fail all at once. It degrades slowly, predictably, and visibly. That matters more than most people realize. Throughout history, the most reliable survival tools have not been the most advanced. They've been the ones that continue working under neglect, under stress, and under conditions where precision is impossible. This method fits that pattern. It doesn't rely on perfect inputs. It works with what's available. That's exactly why it has persisted, even when forgotten. What ties all of this together is not just chemistry or engineering, it's attention. Every civilization that discovered this wasn't searching for innovation. They were paying close enough attention to notice patterns others ignored. That's the real lesson here. The difference between someone who struggles and someone who adapts under pressure is rarely access to tools. It's the ability to recognize what works and to trust it long enough to use it properly. This method has been tested by time in a way few modern solutions ever will be. It doesn't need branding, upgrades, or replacement cycles. It simply does what it's supposed to do, over and over again, as long as you understand its limits and apply it correctly. And that's where you come in. If this shifted how you think about something as fundamental as water, then it's worth taking further. Subscribe to the channel. Share this with someone who takes preparedness seriously. Keep pushing deeper into the knowledge that actually holds up when it counts.